So we will discuss now about the carry look ahead adder. So as the word suggests, okay, carry look ahead adder, or sometimes this is also referred to as look ahead carry generator. Okay. So the reason why we call it as look ahead carry generator is this is upfront generating the carry values so that we don't have to depend on the subsequent or the previous carry to be generated. Right. So this is one speciality of this look ahead carry generator. So as we all know, okay, the equation for the full adder, okay, is x is XORed with y and XORed with your carry, right? So we are trying to do a small change here. Instead of directly giving C in, we are trying to give it through a carry look ahead logic here. Okay. So what is this logic involved? So we will actually look into it in detail. Okay. And the reason why we are using this kind of generator is that, it reduces our time, time for generating the carry. Usually what happens is we have to wait for carry to be generated from one block to another block, right? When we add 1 and 1, okay, it's 0 and then carry gets generated. So only after this addition process, okay, we get to know that carry is getting generated, and it needs to be propagated to the next value. So here with the generic, or the process that was involved previously, okay, there is a lot of delay involved. But with this, what we are doing is we are trying to analyze and we are trying to generate the carry beforehand, okay, beforehand, and we are trying to provide it, and hence it is called uh, look ahead carry generator. Okay, so this figure is referring to how your C in is getting generated. Okay, C in is getting generated. So these are your outputs. Output here I am referring to as C out to J, and these are your inputs xj minus 1 x naught, okay, till x naught, yj minus 1 till y naught, and then C in naught, the initial carry. Okay, so here this is a full adder circuit. I think all of you are very much aware of a full adder circuit, right? We have sum and the carry. So there are two new terms that are getting introduced here. Okay, it is nothing but Pi and Gi. So Pi is referred to as propagate and Gi is referred to as generate. So whatever values are generated here, it passes on to the next level, and hence it is called propagate. This is called generate because it is checking for only high values. Only if AI and BI is 1, then only it will generate 1. If one of the values are low, if either A or B, one of the values are low, then of course we are going to get a 0 because this is a AND gate. So we know that this is an XOR gate. If the values are same, then it is 0. If the values are different, then it's going to be a 1. Okay. So Pi and Gi is propagate and generate respectively. So you can see that Ci, or initial carry, is actually given to the XOR gate at the second stage XOR gate. Okay, so this is the first stage and this is the second stage XOR gate. And the same is also connected to AND gate, and we are generating the next carry, which is Ci plus 1, the next level carry. Okay, so now if we have to write the terms, okay, of Pi and Gi using the inputs A, I, Bi, so we can use, or we can generate the equations in this fashion, right? So AI and Bi are XORed with each other. AI and Bi are multiplied with each other because it's a AND gate. So Pi is equal to this equation, and Gi is equal to this equation, right? So now we can also refer, or we can try to write the values of Si and Ci plus 1 in terms of Pi and Gi, right? So Pi is already here, right? And I am giving the value Ci. So Si is equal to Pi is XORed with Ci, right? Next, if I have to write this in terms of Pi and Ci, then Ci is coming in here and Pi is here. So Pi, Ci is the value that I get here, and then Gi from this output of AND gate, the first stage AND gate. So all these are added together and I will get something called Ci plus 1, right? So why are we doing all this? We are now trying to bring things in the form of propagate and generate. Okay. So Pi referring to propagate and Gi referring to generate. So all the equations we are trying to bring in the form of propagate and generate. So Si in terms of propagate, carry in terms of generate and propagate, right? Okay. Now, if we have to write the equation, okay, if we have to write the equation, so since we have uh, I value, okay, we have to, actually put S1, okay, I is equal to 1. If I put I is equal to 1, so it will be S1, and here I is equal to 1, then 1 plus 1 becomes 2, so it is generating C2. So here G1 because I is equal to 1 and P1 C1, right? So C2 is equal to G1 plus P1 C1. Similarly, if I increase the value of I, okay, to 2. So 2 plus 1 gives me 3. Similarly, it is G2 plus P2 C2. Now I know that my C2 value is G1 plus P1 C1. So G2 remains the same, P2 also remains the same. C2's value I am substituting here in the form of inside the bracket. Okay. So the same thing I bring it down G1 plus P1 C1. The next thing that happens is the normal multiplication between these two terms, right? So you have P2 G1 plus P2 P1 C1, right? So you get a final equation for C3. So you can see that C3 is not dependent on the previous value C2, right? You cannot see any C2 here, right? So C3 is getting generated with the same time as C2. Right? Similarly, now let us see C4. So if I have to generate carry 4, then here I have to increase the value of I. So this becomes G3 plus P3 C3. Now I have the value of C3, okay, and I have the value of C2. So first I will try to substitute the value of C3. So G3 plus P3 G2 P2, okay, into C2. Okay, so C2 value is G1 plus P1 C1. So this one I have multiplied here and I have got it directly. Okay, so which means what I will do here is G2 plus P2 G1, because C2 value is what? G1 and P1 C1. So I will be putting that in the bracket here and I have directly multiplied, right? Okay. So similarly, G3 plus P3 into G2, we are just multiplying terms. P3, P2, G1, then P3 into P2, P1, C1. Okay. So here also you can see that this C4 doesn't have any values of C3 or C2. It only has the value of C1, right? So which means C4 also gets generated along with C3 and C2 at the same time. So it's not dependent on C3 and C2. Okay, it's only dependent on the initial carry. Initial carry anyway we know, right? We know what is this initial carry. So using that, we are trying to build equations, and we are trying to build a kind of um, substantial values which will actually help us in finding out the fast carry method. Now, if I have to put this in the form of SOP form, okay, which is sum of product form. So all of these are in the form of products, and these are sum. So sum of products. Product, for example, we can say P3, P2, G1. This is a product, and this is a sum, right? Because I have a plus here. So sum of all these products, right? So I can say P3, G2 is a product term. P3, P2, G1 is a product term. P3, P2, P1, C1 is a product term. So all these are added. So sum of product. So as you can recall in the previous lectures, right, we had seen SOP form, POS form, right, product of sum of product. So this is in SOP form. So we can implement this with the help of AND gate, because this needs to be multiplied here. And for the purpose of addition, we use OR gate, right? So let us see C4 example. So I have G3 directly coming through, right? G3 plus P3 into G2. So P3 into G2. So for G2, okay, I will be taking it from here, okay, G2 value. So this will be multiplied here, okay. Next I have P3, P2, G1. So P3, yes, I can get it here, okay. G1, I am connecting it here to G1, right. Then for P2, right, I can connect it here, right. So similarly, you can see that this produces the value P3, P2, P1, C1, right, this AND gate. So all these values are given here, and finally it is added, and I get value C4. Okay, so C4, C3, and C2, all of this gets generated at the same time. C4 doesn't have to depend on C3, C3 doesn't have to depend on C2, but all these are dependent on C1. Okay, C1 is already known to us. So using C1, we have built a relationship, and that relationship is done with the help of this equation, right? Okay. So hence it is called look ahead carry generator. Now we will have this also, okay, in the form of IC, okay, and you can see that, okay, uh, C4 is getting generated, okay, as I told you, your C4 gets generated along with C3 and C2, because it's not at all dependent on them, right? Just see the equations. You don't have any C3 term, you don't have any C2 term. Similarly, in C3, you don't have any C2 term, right? They are only dependent on C1. Similarly, here it is dependent on C1, right? Okay. So this is a 4-bit parallel adder, okay, and we have the generator in between. So I'll be giving the inputs A, B, and we'll be getting the propagate and generate values. From this, we actually pass on to the next stage. So remember I told you, so this is the first stage. If we just logically draw a line here, okay. So this is the first stage, which is having Pi, Gi values. And when these values are passed to the next level of gates, okay, we call it as the second stage, right? So in the second stage, in between, we are actually adding the carry look ahead logic, right? So that same thing you can see here, propagate and generate. Then in between we have this carry look ahead adder. So processing happens here, which means the formula is actually here. And with the formula, okay, we get these equations. With the equations, we have this circuit. So behind or internally, this carry look ahead generator will actually have these circuits to generate C4, C3, C2. Okay, right. So C2, C3, C4, C5. So once those values comes out here, okay, how are these values coming out? With the help of these circuits that we just saw. So this circuit will be inside here. So P and G values are given because I need only P and G values, right? You see your general equation. I need only P and G values and the initial C value, right? So initial C value is known to us here with the help of C1. Then I have P and G values. So using these three terms, I can generate C2, C3, C4, C5, right? So once I have this value, P4 is connected to the next stage. So with the help of P4 and C4, I get my sum 4. How is this? Let us get back to our basic equation, right? Just see your PS is equal to your P and C are XORed, right? So if I have the third stage S3, then P3 plus C3, right? So S4 should be giving me C4 and P4. Similarly, S3, I should be adding P3 and C3. S2 should be added with P2 and C2, right? S1 with P1 and C1. So C1 is taken from here, right? So what we have discussed here, with the help of carry look ahead adder, we are able to generate carries which can equally generate at the same time. It doesn't have to depend on the previous carry values. Okay, so generating at the same time, so which means we are reducing delay, which means the circuit becomes faster and it becomes more reliable, right? So this is the first stage of circuits and this is the second stage of components, right? So students, you have any doubts here with respect to the carry look ahead um, generator? Yes, have you all understood?
Yes, sir.
Okay, thank you. Thank you for the response. If you've got any doubts, then you can feel free to ask. Okay.